Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. In the previous session, we learned about fuel cells, the cells which function on the combustion reactions, which are also of redox type, and those can be used to generate electricity. So we learned about a hydrogen-oxygen fuel cell in the previous session. We learned about the construction, the working, that means the cell reactions occurring at anode and cathode, as well as the net cell reaction. And we learned that the net cell reaction gives water as the final product. Hence, these cells are non-polluting cells, and they provide electricity of about 70% efficiency. That means we learned about the advantages of these cells as well. Now, in the today's session, the remaining part of the fuel cell, we will complete that. And then the last part of this lesson, that is electromotive series or electrochemical series, we are going to learn about that also. Hence, the lesson will be finished in this session. Now, we will start studying about fuel cells. The remaining part is drawbacks. What are the drawbacks of fuel cell? The only drawback is related to that of hydrogen gas. The hydrogen gas is hazardous to handle, and the cost of preparing hydrogen is also high. That is the only drawback of fuel cell. Now, the applications of fuel cell, that means where it is used. The fuel cells are nowadays used on experimental basis in automobiles, that means vehicles. They are trying, can we use fuel cells in vehicles? The second advantage or application is that these are used for electrical power in the space program. That is very important use of this cell, because the fuel cells are non-polluting and they can be run continuously by supplying the reacting species. Hence, these are used for electrical supply in space program, that means in spacecrafts. They are operated, and at high temperature, the final product, that is water, gets converted into steam. That steam is condensed, and the pure water obtained is used for drinking purposes by the astronauts. That means it is very, very suitable for spacecrafts. As it is non-polluting, it can be run continuously by supplying hydrogen and oxygen, as well as we get pure water from it. The next application is, in future, these cells can be used as power generators in hospitals, homes, hotels, etc. So this is all about fuel cells, its applications, its advantages, its drawbacks, etc. Now we will start with electrochemical series, or it is also called as electromotive series. As the name suggests, it is a series. That means the standard potentials of number of electrodes have been determined by using standard hydrogen electrode, and then these electrodes with their half reactions are arranged according to their decreasing standard potentials, and this arrangement or this series is called as electrochemical series. That means standard hydrogen electrode, it is a reference electrode. By using standard reference electrode on one side, various metals and their metal ions, that is used as another half cell. One half cell is SHA, another is your determined or any electrode you can take of your choice, and then the standard potential is determined. You get some values at standard conditions, and then all of them are arranged in the decreasing standard potential, in the order of decreasing standard potentials, and that series is called as EMF series. That means, in short, we can say it is a data a very big data related to the elements that are in the periodic table, and from that we can easily construct any cell. That series is very important. Only some conditions are there, some key points of the series we should learn, and then we can use, or it can have various applications. Okay, so let us see what are the key points of electrochemical series, how that series is actually prepared. The first and most important thing, the half reactions are written as reductions. That means those reactions written in that series are all reduction reactions. Then you know that metals generally they don't undergo reduction. That means in case of metals, the cations of metals are taken and those are converted into neutral metal atom by gaining electrons. And in case of non-metals, those have natural tendency to undergo reduction. Hence, all the non-metals accept electrons and get converted into anions. So, the pattern is fixed. That means all the reactions written are according to their reduction, or as if they undergo reduction. Okay. Hence, if you observe the series, we see that the oxidizing agents and electrons appear on the left side of the half reactions, and the reducing agent array are shown on the right hand side of the half reaction. Understood? So this is the pattern. Now the second key point is, below hydrogen electrode the negative standard potential increases, and above hydrogen electrode the positive standard potential increases. That means at the center there is standard hydrogen electrode written, which has zero potential as we know. So above that standard hydrogen electrode, the positive standard potential increases. That means the element which has highest tendency to undergo reduction will be at the top of the series, and that is naturally fluorine. Fluorine is the strongest oxidizing agent. What is oxidizing agent? The one which brings about oxidation by undergoing reduction itself. So fluorine is the strongest oxidizing agent. It has highest positive standard potential value. Hence it is at the top. And the series has the one which has least tendency to undergo reduction will be at the bottom. And at the center there will be standard hydrogen electron. So because the series has the arrangement in the decreasing order of standard reduction potential. Understood? Now, the third, these zero values apply to the reduction half reactions that occur in the forward direction. In the forward reaction, the reaction is reduction reaction. Hence, the E0 values written on the right side belong to reduction half reaction. Hence, those having tendency to undergo oxidation, then naturally they have negative E0 values. Hence, the EMF series which has all these key points applied. One more is that higher E0 value for a half reaction indicates it has a greater tendency to occur in the forward direction. That means it has a tendency to reduce. Exactly opposite to that, more the negative value, that means lower will be the E0 value of a half reaction. That means those have greater tendency to occur in the reverse direction, or they have greater tendency to oxidize rather than reduction. That means below SHE, if you see the series, then you will understand that below SHE there are metals and above SHE there are generally non-metals. The half reactions are listed in order of their decreasing tendency in the forward reaction. Naturally, those having higher values are at the top, and those having lower tendency of reduction will be written below, or we can say below SH. So the EMF series, we will have a look on this EMF series. As it can't be accommodated in one frame, I have divided it in three parts. The first part or the upper half is like this. At the topmost position there is fluorine with highest positive E0 values because fluorine is the strongest oxidizing agent. It will never undergo oxidation. Now, below that you can say when it is a metal, the cations of metals are used. They will accept electrons and form neutral metals. If it is a non-metal like chlorine, those will accept electron and will get converted to an ion. That means in forward direction we have to write reduction reaction only, all the reduction reactions. That means on the left hand side all the oxidizing agents are written. Those will accept electrons, will undergo reduction. Oxidizing agents, that means they have a tendency to oxidize another element by undergoing reduction itself. Understood? Now, the middle part of the EMF series, you can see here hydrogen with zero potential. Above it, the positive value goes on increasing. Below it, the negative value goes on increasing. That means reduction is reducing. The value is increasing. That means all these elements, they have less tendency to undergo reduction. They have natural tendency to undergo oxidation. Hence, the value, negative value goes on increasing. Actually, that means the value decreases. And the last part of the bottom part of this series is like this. Here, lithium, potassium, sodium, which are in the first group, they have natural tendency to undergo oxidation, but their cations are written. By accepting electron, those will get reduced to the neutral metal, and during this reduction process, they show the negative E0 values. Now, this much data we have this series, complete series is like this. This is upper part, this one is middle, and this one is the lower part. This total series you can see in your textbook as well. And by observing this series, by getting this much data, we can have various applications of electrochemical series. Easily we can identify the oxidizing agent, the reducing agent, the spontaneity of the redox reactions. So the applications are so many because we have collected the data, and that data is called as EMF series or electrochemical series. Now, in the exam, they may ask you about the key points of the electrochemical series. They never ask to write the series, but they can ask you to write the key points of the electrochemical series as well as the applications of electrochemical series. So let us see the applications of electrochemical series. As I told you, the first application is relative strength of oxidizing agents can be determined by observing this series. As you know, E0 value is a measure of the tendency of the species to accept electrons and get reduced. All the species which are written on the left side of the half reactions are oxidizing agent. Which one is the stronger than? The one having highest positive value of E0 will be the strongest oxidizing agent. Hence, the species in the top left, the species in the top left side of half reactions are a strong oxidizing agent. For example, fluorine. It has the highest positive E0 value and hence it is the strongest oxidizing agent. As we go down, the strength of oxidizing agent will go on reducing or decreasing. So, relative strength of oxidizing agents, we can just compare the values and can find out by observing the EMF series. On the contradictory to that, we can also find out the relative strength of reducing agent. The one which has a natural tendency to undergo reduction is written on the top, and reducing agents are the one which brings about reduction by undergoing oxidation, and these agents which are written in the lower half or below standard hydrogen electrode. Hence, The species on the right side of the half reactions are reducing agent. The half reactions at the bottom of the table with large negative E0 value have a little or no tendency to occur in the forward direction. They tend to favor the reverse reaction. That means the species appearing at the bottom right side of the half reactions have large negative E0 values, hence they are strong reducing agents. So as we move down, the reducing agents, their strength will go on increasing. Now, one more advantage of this, that means the strength of reducing agent increases from top to bottom. Now, the last application is spontaneity. Spontaneity of redox reaction. Now, redox reaction, that means combination of reduction as well as oxidation. Where does it occur? It occurs in electrochemical cell. And we have a formula to find the E0 value of a cell by, what is the formula? EMF of the cathode minus EMF of anode will give you E0 cell value. Now, if the E0 cell value is positive, then because on the left side we are writing cathode values, hence if E0 cell values comes positive, then we can easily say that the cell can work. We can determine the spontaneity, the reaction is spontaneous. And to find out the spontaneity of reaction, we can use this EMF series. Now, a redox reaction is spontaneous only if the species with higher E0 values is reduced and the one with lower E0 value is oxidized. Natural. The standard cell potential must be positive for a cell reaction to be spontaneous. The application of this series is for the prediction of spontaneity of redox reaction from the knowledge of standard potentials. Now, we'll take one example. For example, suppose a question is asked like this. At standard conditions, would Ag plus ions, because it is a metal, Ag plus ions can oxidize metallic magnesium? To answer this question, first we write, the first thing is write down the reactions. We write oxidation of Mg by Ag plus. And the reactions, those take place will be like this. As magnesium will undergo oxidation because oxidation of Mg. So, the question is, can Ag plus ions oxidize metallic? Can Ag plus ions act as oxidizing agent? That means Ag plus will undergo reduction. Hence, naturally, magnesium will undergo oxidation because it will work as anode. So, this is the reaction of oxidation, anodic. Now, Ag plus ions, those will be at cathode and they will undergo reduction by accepting those electrons coming from anode and will get converted into metallic silver, and this is cathodic reaction. What will be the net cell reaction or overall cell reaction then? We'll just add these two reactions by cancelling the common two electrons and we will get this. Magnesium reacts with 2Ag plus 2 ions gives Mg plus 2 Ag. This is overall cell reaction. And suppose we will calculate the E0 cell by observing the EMF series and by getting the values of E0 of magnesium as well as E0 of Ag plus, and will determine then whether the reaction is spontaneous or not. So, from the table, we get that E0 of magnesium is minus 2.37 and E0 of silver is 0.8 volt. And what is the formula then? E0 cell will be equal to E0 cathode minus E0 anode, that means E0 Ag minus E0 Mg. We will substitute the values and we will get that the EMF or E0 cell will be equal to 3.17 volt. As EMF we got is positive, the cell reaction must be spontaneous. Thus, we can definitely say that silver ions can oxidize metallic magnesium. So, this is the application, or we can say a very good application of EMF series. Now, the general rules for EMF series are like this. An oxidizing agent can oxidize any reducing agent that appears below it. In short, we can say that the one which is located at the upper side will oxidize the one which is located at the lower side. It cannot oxidize the reducing agent appearing above it in the electrochemical cell. Just we have to remember this. So, in the reverse, we can say, and reducing agent can reduce the oxidizing agent located above it in the electrochemical series. That means the one which has a natural tendency of reduction, that means the one which is located at the upper level, will definitely oxidize the one which is located at the lower level. So this is the advantages. These are the applications of electrochemical series. So this is all about electrochemical series, which is like this. One more look at it and you will understand it a better way. The one which is located at the above level, upper level, the left side species are oxidizing agent and their strength increases like this. Right side, the strength decreases in this direction. So the one which is located at the upper side will definitely reduce the one which is located below it. So just by observing, we can determine the spontaneity of the reaction. We can construct easily any electrochemical cell just by taking the reduction and oxidation or cathode and anode from the EMF series. Now, the assignment based on today's EMF series. The first question is, explain key points of electrochemical series. You have to write those. And secondly, write down the applications of electrochemical series. And these are very important. In the exam, many times a question on applications has been asked. Particularly, any application is asked. Sometimes they ask in general about the applications of electrochemical series. As there are 3 applications, the question for 3 marks can be asked. So, you have to write these answers of these questions and send it on my personal WhatsApp number. Thank you.